Good morning, or nope, good afternoon. We are starting binder number 3 today, book 3, and we can see it's PO46 all the way to CO70. This is our final binder of the year. So we really need to pay attention, make sure that we are understanding all of the concepts, that we are ready for algebra next year. So if we look at our table of contents, we can see all the things we still have to learn about this year, starting with Unit 8. Unit 8, we're going to be focusing a lot on those function tables and graphing them, learning new things. So we might start with something that you understand, and then remember, we always build on that to things that are new for us. So I don't want us trying to work ahead and potentially be doing things wrong. So we need to pay attention and follow along in the class. Lucas? I'm sorry, what?
Isn't a PO a bunch of objectives like concepts compiled together?
So it's a power objective, something that we definitely need to know. So what it tells me, looking at our very first one being a power objective, it means that there's going to be stuff that we've learned in the past, and we really need to understand how it works because it's going to help set us up to have a successful whole unit, because we need to understand this objective completely for the rest of the objectives to really make sense. Yes. Mr. Schultz loves his 55. 55. All right, so let's look at PO46. Lucas is right. It is a power objective, and a lot of times we don't start off our unit right away with that power objective. We're starting off right now with the power objective. I can create a function table for a given equation. If this whole unit is working with function tables, is it important to really understand the function table at its root? Yeah. We have to understand what it's all about so we can build on that. So there are some vocab words that we need to know when we're talking about a function table. We have the input. Input is what you plug. Oh, it's still not working. It wasn't working for my other class. It's not working for me now, so I am going to do something a little different. I have my blank binder that I am going to write on instead of on the smart board. I'm going to use the document camera because it's not working. So we're going with it and making it work. So instead of using this, I am going to use this. Because technology is not always my friend. So we are making it work. So the input is what you plug into an equation. Another way of wording it is what's being tested. So it's what we're putting into that equation. So we put something in, we're going to get something out. The output is the result of the equation or test. So input is what you put into the equation. The output is that final result, what you get out of it. Now I'm going to take this out from under it because that spine is making it hard to write. All right, so the equation or function table. This whole unit's about function table. We really need to know what function table means. A function table is a way to organize multiple inputs and outputs to get ordered pairs for a graph. And we're going to see what that looks like, how we organize it to make sense. So the equation we get from a function table is also known as the rule of the table. So we say, oh, we're always, sometimes when we look at the pattern pages in the math packets, there's a rule that we're following. Oh, we're adding 4 each time, or we're looking at those perfect squares, right? And we're working with those perfect squares. So that rule is that pattern that we're following. So we're going to create a function table with at least 4 inputs and outputs for each equation given. So we're going to really show that we understand how it works. Remember, this is important. You can choose the inputs for your table. So we're going to choose smart ones. And we're going to see what that means. We're going to look at what numbers make it the easiest to work with. Okay, so we really want to look at what our smart choices would be. So let's look. When we really talk about smart ones, we really want to look at those fractions. Can we work with decimals? Sure. We can make fractions into more fractions. What's easiest to work with when we're adding or subtracting? What's easiest to work with, Henry? What kind of numbers? Fractions or whole numbers?
Whole numbers.
Whole numbers are a lot easier, right? So if we look at 1/4 and we're multiplying it by our inputs are always the x's and our outputs are the y's. So our function table, we're going to have x's and y's. Just like our ordered pair, the x always comes first, the y always comes second. Because we talked about a function table we use to get ordered pairs to graph them. So we want to set that function table up so it's easy to see those ordered pairs. We're going to look at what we're going to put in for that x to make it easy numbers to work with. So if our input is our x, what might be a smart number to put in for x for this equation? Henry? Maybe a 4. So I could say 1/4 times 4 plus 7. What is 1/4 times 4?
4.
Nope.
No,
1. So this would be saying 1 plus 7. So my output, x or y equals my output. If I put a 4 in for x, what do I get for y? 8. 1 plus 7. Now, could I put in any whole number? Sure. But that doesn't give me an easy output. I like working with whole numbers. So I like when I see fractions, I use multiples of that denominator. So I get whole numbers. So if I see a 4 there, I would use an 8 next. 1/4 times 8. You guys got to let me know when I have to move up. 1/4 times 8 is what? 2. 2 plus 7 is what? 9. So now I have my next one. I would do my next multiple of 4. 1/4 times 12 is what? 3 plus 7? And then my next input I would put is 16. 16 times 1/4 is what? What's 4 plus 7? So when you get to choose those inputs, you choose numbers that are easy for you to work with. It's easy for me to work with whole numbers. So I'm going to choose those multiples of my denominator so I get a whole number. Are there other ways to do it? You bet. Would you be wrong if you chose different inputs? Nope. As long as your output is correct. I like to choose easy numbers so that way I don't make simple math mistakes. So let's look at this first one here. Remember, I set my function table up with the x and the y. I need to have at least 4 x's. This one, it's just x plus 3. What should I use? What would you think would be a good input to put in? Grace? 1. Okay, if I put a 1 into x plus 3, what do I get out of it? Damien? 4. Because 1 plus 3 is 4. So x is 1, I put that in, and then y is what I get out. What should I put for my next one? Lucas?
428.
I could do 428. What do I get out? 431. What should I put in for my third number?
8.
James?
5.
5. What would I get out if I put in a 5?
8.
What should I put in for my next one? Addie?
97.
What would I get out of that?
100.
Now, is this function table correct?
Yeah.
Yeah. Each of those inputs, that's what I get as an output. Can I see a pattern in there? Can I see a pattern looking at it like this? No. If you didn't, there's no pattern here. If I went and said, okay, I'm going to go in order, and I'm going to put a 1, 2, 3, 4 in, and then I go up 4, I get 5, I get 6, I get 7. Is that easier to see a pattern?
Yeah.
It's easier to check to make sure that you're not making one of those simple math mistakes. So when I do it personally, I like to go in numbers that go in order because I don't want to make a simple mistake, and it's a way of double checking. Does that mean putting in any numbers wrong? Absolutely not. You can do that, but it's a lot harder to see it blatant that you made a mistake. Okay. When you do it as a pattern and you go in order, you can really see, oh, that number doesn't make sense. Why did I go from 4, 5, 6, and now all of a sudden I put in 8? Wait, I think I did something wrong. It's not following the pattern. And then I would go back and double check, because we all know that when we do math quickly and we go, oh, this part's easy, and we go too fast, we make simple mistakes. And on the test, you get it wrong. So I prefer to double check my work the easy way. On the test, if you did it this way, it would be right. But you're also at a bigger risk of making those mistakes. I'm going to erase this so I have room. Let's look at this one. If I put in that X and Y, I'm going to make my 4 spots because I need at least 4 inputs. What would be a good number to put in? I'm hearing lots of stuff being called out. Lakely, what do you think I should put in?
1.
Okay, if I put a 1 in for my input, what's my output going to be? Madden?
-9.
How did you get -9, Madden?
Because it's 1 times second power, and then it's 1 minus 10.
Yeah, so 1 to the second power. 1 squared is 1 times 1, which is 1. So 1 minus 10 is negative 9. Like I said, I like to go in order, so I'm going to go in order with this one so we can see our pattern. So if we started with a 1, I'm going to put a 2. If I put a 2 for my input, what is my output going to be? Emerson, how did you get negative 6, Emerson? 2 squared is 4. 4 minus 10 is negative 6. So now I'm going to put a 3 in for my y. What is my output going to be, Grayson?
Wait, for 3?
Mhm.
Is it negative 1?
It is negative 1. How did you get that, Grayson?
I did 3 squared, which should be 9, and then minus 10.
3 squared is 9. 9 minus 10 is negative 1. So now I'm going to put a 4 in. What is my output? Lauren? How did you get 6, Lauren? 4 times 4 is 16. 16 minus 10 is 6. Is there a pattern that we're seeing?
Not really. Yes.
Yep.
Madden, what pattern are you seeing?
It goes. It's like on the Y. It goes from 3 to 5 to 7.
9 to 6 is 3.
The spacing apart, right? So on the number line, negative 9 and negative 6. I miss not being able to write on my board. Negative 9. Oh, how fun! Okay. So negative 9 to negative 6 are 3 away.
It's just an eraser. It's not point. Try it now. How do you make it different?
So negative 9 to negative 6 is 3 away on the number line. Negative 6 to negative 1 is 5 away on the number line. Negative 1 to 6 is 7 away on that number line. So we can see how that spacing is getting bigger and bigger, right? It's going up farther. So you can see if we had all of a sudden a 2 here, oh, I made a mistake somewhere. It's easy to see that number doesn't make sense. It's too close to that negative 1. You have to look at it logically. Does it make sense? You're going to create your own 2 function tables for those 2 middle ones. So we are going to switch back to my board because I like writing on the board so much better. So you're going to do these 2 on your own. Let's look at the rest of this page. After a week of timing yourself during your morning run, you discover that you can run 4 miles per hour. Let H represent the number of hours you run, and D represents the distance you run. So we've worked with function tables before. Now we're creating the rules to those function tables. So A, what is that input going to be? Let's listen to those directions again. After a week of timing yourself during your morning run, you discover that you can run 4 miles per hour. Let H represent the number of hours you run, and D represent the distance you can run. So what do you think our input is going to be, Emerson? H for hours. Oh,
It only works it can't touch text. It has to.
You're right. It only works on the document camera. So that's okay. So we'll put it on the document camera, but I'll write on the board. Okay. So what is the input? The input is the hours. I'm gonna put in a number of hours, and what am I gonna get out of it? The distance. Yep, the distance that you run. So write an equation that relates the input to the output. If I can run 4 miles per hour, what do you think my equation is going to look like? Jude?
Would it be hours, wait, 4 equals, wait, no, never mind.
All right, keep looking at it. What do you think, Lucas?
D equals 4 times H.
What do you guys think? Show me your thumbs. What do you think? Do you think our equation would be D equals 4H, or do you think it would be something else? Peyton, what do you think it would be?
Yeah, I think it's yeah.
Okay,
Yeah.
so we can run 4 miles per hour. So every hour I run, I can go 4 miles. That's why we're multiplying. And that's going to give us our distance. 4 times those hours gives us our distance. That is absolutely correct. Now it says create a function table that will show how far you will run in 3 hours, in 8 hours, in 12 hours, and in 20 hours. So is my hours my X or my Y?
It's
It's X because it's the input. The input is our X. The output is our Y. So I can put X, Y, I can put hours and distance. But it has to be whatever's representing the X goes first. The input always, always, always goes first. Output always, always goes second. Just like when we graph, it always goes X, Y for our ordered pairs. So we're going to get ordered pairs out of these function tables. I have to put in, I have 4 different things I'm doing. What am I going to use as my first input? Grace? 3. It's telling us what our input has to be. So I'm going to put a 3 in first. If I go 3 hours, if I run for 3 hours, what will my distance be, Henry?
12.
12, because 3 times 4 gives me 12. What's my second input? Christian?
4.
4.
Oh, 8.
8. I have to use the inputs they're giving me. I don't get to choose this time. If they give us inputs, we have to use the ones that we're given. So if I run for 8 hours, how many miles am I running, Fiona? 32, because 4 times 8 is 32. What is my next input I'm going to use, Damien?
12.
12. If I run for 12 hours, what is my distance that I'm running lately? 48 miles. And my last input, Grace said,
20.
if I run 20 hours, how far am I going to go, Adeza?
80.
4 times 20 is 80. Now it says, how long will you need to run to go 62 miles?
Oh, I know where to do it.
If you burn 250 calories per hour of running, how many calories would you burn? So we have 2 questions. Will and Lucas, please stop. We have 2 questions to answer, so there are 2 different things I'm going to do. If I'm running 62 miles, how long is that going to take me? Jude?
15 and a half.
15.5.
How did you find that?
You just 62 divided by 4.
Because we know our distance is 62, and our equation is 4h. So I'm gonna plug 62 in for my distance. I want to do my one-step equation to get my h by itself. So I have to divide both sides by 4, because I want to get that h by itself. 4 divided by 4 is my 1. 62 divided by 4 is 15 and a half. So I need to run for 15 and a half hours to go 62 miles. So when you know an equation, you plug in what information you're being given. If they're giving us the hours, then we plug in the input. If they're giving us the distance, we have to put that in the right spot on our equation. Am I done with this question?
No.
Madden, what do I have to do?
You have to do 15.5 times 250.
Yeah, because I'm burning 250 calories per hour, and I'm running 15 and a half hours. So I need to multiply those together to see how many calories I'm going to burn in this big long run I'm doing. How many calories do I burn, Madden? 3,875 calories. So on the test, if it's asking 2 questions, I would want you to circle your 2 answers. So I know where your final answers are. I know where to look. How are we feeling about this so far? Yeah, some of us are like, I'm getting it, but I know it's going to get more complicated. And it is. Let's look at our second page. Friends, you pick a summer job. Mr. Schultz started working when he was only 14. That pays a base salary of $500. Always start out with $500, your base salary. You always get that $500. And an additional $9 per hour worked. So just by showing up, you get $500. And then for every hour that you work, you get $9. Let H represent the number of hours you work, and M represent the money that you earned. What will our input be? Is it going to be hours, or is it going to be money? Kaylin?
Hours.
Yeah. We don't know how many hours we're going to work. We're going to say, oh, if I work 10 hours, how much money am I going to get? So our input is the hours. Go quick, James. So if the input is hours, what's my output? Chris? Money. So write an equation that relates the input to the output using all the information given to us in our problem. You already know, Grace? What do you think it would be?
M equals 9H.
Show me your thumbs. Do you think that that is our equation, or do you think it is something else? I see a hand, Rowan. Is that a hand? Is that a thumbs up? Or Rowan, you have a thumbs down. Why do you have a thumbs down?
Because you have to add the $500 to get.
We can't forget we have a base of $500. You always start with $500. So, oh, I'll wait. Rowan, I'm sorry, Kyle. How would we put that into our equation? Yeah, because we are always starting with $500. We're going to add that to our 9H. because that's our base. We always start with $500. So we have that, and we're adding on the hours that go into it. Does that make sense? So you always have to look, am I using all the parts of the equation? And how am I going to use it? It's a base. I always get $500. That means I'm just adding it to it. So now it says create a function table that will show how much money you will earn after working an hour, a day, a week, and a month. So I've got my hours and my money. My input is my H. My output is my M. What is my first input? Grace. 1 hour. Working an hour, 1 hour. If I work 1 hour, how much money do I get? Damien?
$9 or
$509. $509. What is my second input? Henry?
8.
Because I need to put it as hours, right? So I work a day, which is an 8-hour day. So there's 8 hours. What is my output if I work 8 hours? So Olivia, what I write on the board is not for my benefit. This is for everyone, and we all need to be writing this. Grace? I'm sorry, what did you get? If we put in 8 in for our hours, what's 8 times 9? 72 plus 500. Grayson? Plus 500.
572.
572. What's my next input, Lately? How did you convert it to hours? So we're going to look right there. How many hours do we work in a day? Do we work every single hour of the day? Oh my goodness, I would be dead if I was working every single hour of the day. Do we know how many hours we work in a day? 1 day is 8 hours. So if we're working a week, which is 5 days, so if it's 8 hours a day and we work 5 days, how many hours is that lately? 40, much more doable number. If I work 40 hours, how much money am I going to get, Emerson? 860. What is my last input? Emerson? 160. Because we know 1 week was 40 hours, and I have 4 weeks. So 4 times 40 is 160. If I work 4 weeks, if I work for a month, how much money am I going to have? Will? $1,940. So it gets a little more complicated, all right? They're not giving us simple, super easy inputs. We have to use our math brains and really look at if we're talking hours, and if they tell us it's 8 hours is a day, I have to use that information for the rest of them. Now we have E, about how many hours do you need to work to earn enough to be able to deposit $750 into your savings account. How many hours would we have to work? How should I solve that? What do you think, Fiona? Okay, so 750 is our money. Now Fiona said divide by 9 because we know it's 9H, but then Grayson mentioned something. Grayson, what did you say? We can't forget about that 500. So if we have 750 equals 500 plus 9H. When we do our two-step operation, we're doing it backwards, the order of operations. So we have to subtract 500 first from both sides. So that gives me 250. 500 minus 500, we zero out. So 250 equals 9H. Now what do I do to find the hours? Matthew?
Divided by 9.
You're right.
250 divided by 9.
I need to divide both sides by my 9. So I'm dividing by 9. 9 divided by 9 gives me just H. 250 divided by 9 gives me what, Matthew?
27. Just rounded up to 28. So basically 28.
28 hours. What is that my final answer? Why not?
Because you still need to figure out how many more things there is.
That's how many hours I need to work. Now I need to answer my second question. About how many work days is that? Christian?
Like 3.5.
Yeah. 28 divided by our 8 hours. That would be about 3.5 days. Because 8 times 3 is 24. 24 up to 28 is half a day. So it's about 3.5 days. Let's look at our next one. Your cell phone bill reported you spent 80 hours on the phone last month. You agreed to decrease that time by half each month. Let M represent the number of months and T represent the amount of time you spend on the phone. What is our input? You're agreeing to decrease your time by half an hour each month. So what is it that we're putting in? What is our input going to be? Jude?
Per month.
Your months. What is our output? If month is the input, what is our output going to be? So we already did M is the input. So our output has to be the other one, our time or T. What would our equation be? Write an equation that relates the input into the output. So we've got our number of months and we've got the time you spend on the phone. Lucas, what do you think?
N times 0.5 equal M time times 0.5 M times minus 0.5.
Wait, so remember how our equations are set up.
Excuse the interruption. These are your Monday afternoon announcements. We have one exciting announcement. We have our end of the month blue ticket winners, and we've got quite a few. So if you hear your name, you are our end of the month blue ticket winner. You may come down for your prize. Joshua Munene, Baxter Birkin, Elin Reek, Owen Shornstein, Riziki Momani, Noella Spencer, Madeline Nyko, and Avery Peterson. Awesome job, Royals. Remember to keep winning those blue tickets this month. Have a great day.
Okay, so remember how our equations are set up. Our input is part of the equation and that equals our output. So does that change the way you're going to set that up, Lucas?
Time 1 times 30 minutes minus time. Wait, what?
30 minutes from?
Half an hour.
Kaylin, what do you think?
Would it be m equals time divided by 1.5?
So, remember, our output is the x or the y. The output is the y, the input is the x. So we're going to start with t equals, because that's our output, is our time. What are we always starting with here? What's our constant, Adeza? 80? Yeah. 80 hours. So we had 80, and we're going to decrease. What operation would be decrease? What operation? Add, subtract, multiply, or divide. If we are decreasing that 80 hours, subtracting. And then Lucas was right. It was 0.5 times m. Every month, we're going to decrease it by a half. So every month, we're decreasing it by a half. So we started with that 80, and we're subtracting out half times the month. Create a function table that will show, I used to say, how much time you spend on your phone after 2 months, 6 months, a year, and 3 years. So we create our function table. We've got our month, and we've got our time. We've got our 4 spots. What's my first input? Grace? 2. 2 months. How much time should I spend on my phone in 2 months? Christian? 80 minus. So we have to subtract away. My answer can't be 80 because I'm subtracting something away. So what is 2 times a half? 1. What's 80 minus 1? 79. So after 2 months, I'm only going to spend 79 hours on the phone. It's not a big decrease, but let's see as we go on. My next input is 6 months. After 6 months, how much time am I spending on the phone? Kaylin? 77 hours on the phone. What do I put in for a year? 12 months, because we have to keep it in months. If I spend 12 months, what is my time on my phone going to be, Fiona? 74. And what do I put for 3 years? Fiona? 36. How much time on the phone if I have 36 months? Kaylin? 62. We're not going down by much, are we? We're going down pretty slowly. If you think that 20 hours on your phone each month is reasonable, how many months will it take for you to reach your goal? What do I have to do to solve this? Matthew? I need to put that 20 hours in for my time. And then I'm going to put my 80 minus 0.5 times m. I need to do my opposite operations. So I'm going to subtract 80 from each side. Yeah, you get negative 60 equals negative 0.5 months, because there's a minus here. So that's a negative 0.5 months. So now I need to divide by that same number, negative 0.5, divide by negative 0.5. Negative 0.5 divided by negative 0.5 gives me just the m. What's negative 60 divided by negative 0.5? Matthew. That's what I'm asking for. Is it a negative or a positive?
Positive.
It is positive because it is negative divided by negative gives me a positive. 60 divided by a half, not multiplied, divided by a half gives me 120. So it'll take me 120 months to work down to just 20 hours.
So basically, it'll take you 10 years.
Matthew, what is it that you did?
It'll take you 10 years.
No, I seriously say it out loud. No, because I'm going to show you how we did the same thing. It's just you worked on the positive side and I worked on the negative side. You did 80 minus 20, right? And then you did a positive a half that you divided by. So you just flipped it, right? So we're doing the same thing, and I want you to see that we're doing the same thing. So I hear you just, let's look. We have a work page. We have two problems on this page. We've got the recipe and we've got the building floor plan. You need to get these two problems done. So sometimes we have homework, sometimes we don't. Work on these. We've got 3 minutes. I will give us 10 minutes of work time in class tomorrow. So you need to work on it. You can finish it up in class tomorrow, but the goofiness that's going on right now needs to be done. Use your work time effectively. I will give us 10 minutes of work time tomorrow, but you need to be ready to correct tomorrow this last page. Working quietly right now. If you are watching at home, I hope you are well. Have a wonderful day.